Hi guys, my name is Reno and today I'm going to be teaching you about translations. Alright, so the first topic in translations, we need to learn about vectors. So, a vector is a quantity that has both direction and magnitude or size. So, you learn mostly about vectors in physics when you take that course, but in geometry, we just look at vectors in a coordinate plane. We have a horizontal component and a vertical component, and that's how we use it in geometry, at least for now. This is how a vector diagram would look like, with the horizontal component and the vertical component not necessarily drawn all the time, but this is just for illustration at this point of time. But this is the actual vector. So the initial point is point P and the ending point or terminal point is point Q. You would just name this vector PQ with the starting and ending points PQ. The horizontal component is phi units to the right being the direction and phi units being the magnitude, and the vertical component being 3 units as the magnitude and up as the direction. So, how do you write the component form of the vector? You use curly braces and you write the horizontal component followed by the vertical component. So, as you can see here, the horizontal component is 5, so that's the x in this case, and the vertical component is 3, and that's the y in this case. But sometimes you see this as a comma b, so it's just different variables, but the same topic. So this is how you would write it. If you don't want to write it in words, you just put the starting and ending points PQ, or the name of the vector, and then a half arrow on top representing that this is a vector. That's another way of writing it. Alright, so some vector practice. So in the diagram, name the vector and the vector components. Pause the video, give it a shot, and then come back for the right answer. Alright, so now that you're back, so the answer would be, the name of the vector is vector JK, the starting point and the ending point being the 2 letters in our name, and the vector components are 3, 4, as it goes 3 to the right and 4 up. Alright, so what is a transformation? A transformation is a function that changes the original figure to produce a moved or different image than the original. So transformation is just the general name for the many of the translations, reflections, and dilations that we're going to be learning about. So yeah, when we learn about translations in this lesson, you'll understand the name of the transformations. The original figure could be called a pre-image, and the new figure an image. The points or the vertices in the pre-image are the inputs for the transformation, and the image's vertices are the output. Alright, so translations. So, a translation moves every point in the figure the same distance along or using a vector. You use the components of a vector to translate a figure. So as you saw earlier, the vector had 2 things, the x and y coordinates, or the a and b. So we would use that and add or subtract that to all the x and y coordinates of that figure, add or subtract, so that we can move it or translate it to a different position. Alright, so translating a figure using a vector. So the vertices of a triangle ABC are A 0, 3, B 5, 7, and C 8, 1. And the vector is 5, -6. Write down the new coordinates of the new triangle. Pause the video, give it a shot, and then come back for the right answer. Alright, so now that you're back, the answer would be the new vertices A 5, -3. As I told you guys earlier, you would add or subtract the vector's components to the x and y coordinates of the points. That would be 0 plus 5 and then 3 minus 6, which gives us 5, -3. And then this would be 5 plus 5 and then 7 minus 6, so 10, 1. And then C, 8 plus 5 and 1 minus 6, 13, -5. Writing a translation rule. So, you can write a translation rule in the notation of x and y being the original coordinate, and then x plus a, y plus b. The a and b being the vectors x and y basically. So what you're going to do is write a translation rule for triangle ABC and triangle ABC after it has been translated. Pause the video, give it a shot, and then come back for the right answer. Alright, so now that you're back, the answer is going to be, the translation rule is x plus 4, y minus 1. And the vector was 4, -1. As you can see here, if it's translated 1 unit down and then 4 units to the right, so you're just going to add 4 and then add the -1. Translation postulates. So, translation postulate. A translation is a rigid motion. A rigid motion is a transformation that preserves length and angle measures. So wherever you translate it or move it, the length will not change and the angle measure will not change for a shape. The composition postulate. The composition of 2 or more rigid motions is a rigid motion. So it's just telling us that if you do 2 or more translations or rigid motions, it's still not going to change. The length and the angle measures will still be the same. Alright, so composition postulate practice. So graph RS with coordinates R, -8, 5, S, -6, 8, and its image S after the composition. Translation 1, X, Y, X plus 5, Y minus 2. Translation 2, X, Y, X minus 4, Y minus 2. Pause the video, give it a shot, and then come back for the right answer. Alright, so now as you're back, the answers, the coordinates after translation 1, we're just going to add 5 and then -2, so that's going to give us -3, 3, and -1, 6. That's going to be our red line segment right here. And the coordinates after translation 2, it's going to be R, -7, 1, and then -5, 4. And the green line segment is going to give us our second image, the second translation. So if you found this video educational, leave a like, subscribe, and then come back for more educational videos like this.